Hi, it's Anthony with Lighthouse Construction. We are at a brand new project here on Pelican Lake. We're just starting some of the site work and concrete work. Let's take you on a tour beyond the blueprint. All right, let's take a look at the site work here. So I'm standing and there is notoriously poor soil in this condition. So you can see we've all brought in this pit run material now. But what we did earlier in the spring was we came in here with a drill rig and we went down and we took soil borings. And what we're testing for is to see what type of soil's in the location, because we're concerned about having like peat moss or organic soils where they have a really low bearing capacity. So in that case, sometimes you need to do helical piers or other methods to help cope with that poor soil. In this case, the results came back and the soil engineer prescribed that 4 feet of material needed to be removed and then replaced with pit run material. But we still were contending against a high water table. So I'll show you what we did. Here we have a pump that essentially pulls a lot of the water. They call it dewatering. They do this sometimes on commercial projects. So these PVC pipes here kind of extended below the grade. So it was about sticking up this far from the soil. And that really helps. Every 3 or so feet there were these pipes. And that helps to lower the water table just temporarily during construction so that we could dig out the poor soil, replace it with the 4 feet of proper soil, and really start the process from there as though it was a standard construction. So now let's take a look at how we did some of the footing sizing and the concrete. So let's take a look here inside the garage. So I'm gonna step up here. So what we did was when we brought that soil in, we compacted it in lifts. So you don't want to just pour all the soil back in and then start tamping. You do it in 8 to 10 inch lifts and then you compact each layer. That way you can hit a higher level of compaction. So what we did is we poured the footings and then we put the ICF wall on top of it. And this kind of gives you a nice view of the ICF. So you can see we have a taper cut here. So essentially we've poured the footings in the walls, and then our last pour is gonna come, we're gonna pour 4 inches of concrete in the slab all the way to the top of this piece here. And that's gonna allow us to put our sill plate right on the outside of this ICF so that our sheathing can come flush with the ICF so that we can put our water vapor barrier tieback and waterproofing all the way down on this surface. So let's take a look. The garage space has already been brought almost to finished grade before the concrete pour. But if we take a look, once we go from the garage into the house, you're gonna start to see some of the HVAC system. So what we have here is a PVC HVAC underground floor heat system. So this allows us to run our forced air system in the slab versus the attic space coming down. In this home, that was important because a portion of the front is not covered with a second story, so we weren't able to come down everywhere in the home, as well as they have a lot of glass on that lakeside with nothing above it, so we really wanted to make sure we had proper insulation coming into this space. So as you see here, the mechanical room is about right where I'm standing here, and this is gonna run all those PVC ducts. That's where the downdraft furnace is gonna be, and there's almost a loop going around the home. So that's gonna have all the supply, and then there'll be a separate return air system. So you can see those all neck down to the actual individual runs, and these will be about flush with the final concrete pour. Kind of a unique condition we have going on over here is we have a pad footing. So standard footing size on construction in Minnesota is 10 inches deep, 20 inches wide. And that's to bear your standard 2x6 2-story wall. Where in some of these locations where you have a point load, for example, this is all templated out for a steel column that's gonna hold a steel beam. We actually need to upscale the size of the footing so that I can bear down on the soil and really help to spread that load. Kind of like a snowshoe does when you walk on the snow. It makes you lighter because there's less weight per inch of the footing. So something I kind of drew up here, as you can see here, I'm gonna take a line and draw it right here. This is the end of the second story. And then this is the wall that's gonna kind of carry across. So we're gonna have a steel beam right here, and that's gonna hold up the second story where there's a girt truss coming here. And we ran the calculations and we discovered without doing a big drop beam, we're not gonna be able to achieve that without doing steel. So in this application, there'll be steel columns coming down to hold that and a steel beam. And then there's gonna be a top cord bearing truss running in this direction, hanging on that beam upstairs. If you check out over here, where we haven't quite filled this floor up, you can really see the footing here. This also has a point load on it. So you can see here, normally that footing would come to about here, where in this case, I think it's almost 4 feet wide and still that 10-inch footing. So it's really gonna be a structurally sound place. And you wanna make sure when you're dealing with point loads, you're expanding those footing size to create that snowshoe effect for the foundation wall. So where I'm standing here is right actually on the lake side. So the living room kitchens here, the sunroom's over on this side. And you can see here, we really over excavated this, and that's because we're gonna have a patio and porch that comes out over this space. So we wanted to make sure not only the main structure was on good soil, also this covered porch area is on proper soil, because we want them to move as one with the home. We don't want this to shift separately and create issues down the road. This actually gives you a good view of that dewatering still in place, where all those pipes go down into the earth and then go into the main trunk line for it. And then with outside of the structure, we actually insulate with a 4 feet sheet of foam. So right here, this is kind of a scrap piece here, but essentially those sheets come out, and that helps from any frost getting underneath the footing, because we're essentially trying to protect the footing from any of that thermal grow and expand as the seasons change. All right, 2 weeks have passed since the last time we were on this job site, and if you look around, you're gonna notice the concrete slab has now been poured. Let's take a look at some of the details of pouring a concrete slab. So let's start right over here. You can actually see the garage door is gonna be right in this space. So we taper that so that the water will go outwards, and there's a nice level spot for the sill of the garage door to lay. We have a floor drain in the center of this garage. That's nice, so when water and snow is melting off your cars, there's floor heat in this garage, so that snow is gonna hit the ground, melt, and go right towards that floor drain. If you look over here, I've now stepped, this line kind of represents the threshold between the house and the garage. This is a nice floor drain here, and this is actually gonna be in the laundry room underneath the washer. So in the event that something were to ever happen to that wash machine, there'd be a spot for that water to funnel right into that floor drain. If you step back, I am in the heart of the home, and no, we're not talking about the kitchen, we're talking about the mechanical room here. This has all of the floor heat runs that come up, a nice floor drain, and then actually our water line that's sleeved in and runs directly to the weld location. Now, if you take a look at this slab, there's concrete, there's all those footings underneath here for bearing points, but there's a couple things I'm gonna highlight. One is right here, we have this knockout. So what this is we're gonna have a steel column that goes in this place. So there's actually a concrete big old pad footing that's located here. The steel column is gonna align with these bolts, and then that is gonna extend upwards. And then there's gonna be a nice steel beam that runs all the way here. It's a beautiful breezy day here on Pelican Lake. And the next column is gonna be here to hold that entire floor system and roof load of the second story. One other thing to point out here is we have our floor registers that are all in place. We have a floor outlet right here, which is in the center of the living room. That way, if they have power recliners or a lamp, they'll be able to power that without running ugly cords and trying to hide them with rugs. Right here, I'm in the master bathroom. So you can see we have this recess for the shower, but we also have a nice kick out, and that's because there's gonna be a linear trough drain in this space here. And if you look here, we have some water lines coming up because we wanna avoid water lines on exterior walls in this home. And that is really the bulk of the concrete work. Next, we're gonna start the framing process. So we're back here at the Pelican Lake new build, and you can see that we have started the framing process. We have some of our lumber staged here in the garage space. That way it's nice and efficient to start bringing to the upper levels. We have the garage walls up. You can see this is a 2x6 construction. We have treated plates here, double top plate. So the area I'm standing in is the garage space, and as we move in, you can see that zero entry between the house and the garage, a nice detail for aging in place, those types of things. I'm now standing in what's gonna be the mudroom. You can see this is gonna be a bank of cabinetry here. We have a nice window out to the outside there. You can notice we have our floor drain detail here. This is below the washer and dryer. And then we also have some of our forced air PVC ductwork that was under the concrete. That's been in here as well. And if you take a step into this mechanical room, you'll see where we have our downdraft furnace that's gonna supply that in-slab ductwork, as well as all of our floor heat runs for the house and the garage, and our well water supply line into the house. So let's step back here. You can see the inside walls are 2x4 construction since they're not bearing a lot of weight, as well as they don't need that depth for the insulation value of the home. If you take a look here, you can see that column detail. This has actually now been poured and placed and grouted into position. So you can see where this column actually extends to a steel beam here. And the reason that we needed this is because we have an LVL that holds up all of these floor trusses, and that bears on this point. So in typical fashion, we'd have a post right here. but in this case, the client did not want to post interfering the flow of their living and dining room. So we've been able to transfer that load to the exterior wall and conceal it in this space. So once this home is finished, no one's really going to know that detail, but that just really helps the functionality of not having a column fall in the middle of the working space. You can see here we have these 3 giant openings that are framed. These are all going to be 8-foot tall sliding patio doors to the lakeside. And you can get a look up here at those web trusses. Again, we're using those so that we can run all of our second floor heating and cooling runs in that web space. If you take a look over here, you're gonna see a triple ply LVL. I think this is a 24-inch LVL. And that's actually gonna bear the second floor roof. In this case, this is kind of the matching post location on the other side. So here we were able to do that because it's a lot shorter span and use typical lumber construction material. Again, we've sheathed right over the window openings, so those will all be cut out. And this is actually going to be a nice little sunroom. It's really just a kind of offshoot living room. It's fully conditioned and a part of the home. And then when we step off here, where our dewatering was all set up in place, we now have a nice area prepped for a concrete patio pour off this side of the home. So right here we have the entry door to the home off the roadside. You can see this is a little bit taller than the rest of the openings because this is a beautiful 8-foot entry door. Nice closet space in here so when you walk in from the entry area to hang your coats. And then here we're entering the master suite. So you can see the master suite here has some nice windows, area for a headboard here. And as we walk into the bathroom space here, you can see we're gonna have a nice vanity here. This register is actually gonna be below the vanity, so we're gonna channel that up and duct that out the front of the register so it's kind of concealed within the toe kick of the vanity. And then we have a nice area where we have a toilet that's gonna be roughed in, a window above that. And then here's gonna be that walk-in shower. So this is that detail we talked about last time. This has actually been recessed into the concrete slab. And you can see we've left this part open for a nice line drain. So that drain is gonna run this entire area so that when I'm standing in the shower here, I won't even need a door in this space because all of that water is gonna run into the floor drain here. And this entire bathroom is gonna have a tile floor, so it'll be a really nice and clean look. And then over off on this side, I have a nice area that's recessed for a linen cabinet, so it'll be very flush, look nice and built-in custom. And then over on this side, we have a nice walk-in closet space. Thanks for joining us on this special episode, this 3-part episode. We started talking about that HVAC mechanical rough-in onto the final concrete pour and now onto the main floor framing. Join us for more in the future where we take you beyond the blueprint.